Hi everyone, welcome to today's video, and in this video we are going to discuss about the null hypothesis, alternative hypothesis, the p-value and the common misconceptions around these concepts. Okay, so what is a null hypothesis? It is like a default setting in statistics. So what do we mean by that? We mean by that is that whenever we start a study, we don't assume that there is an effect of the drug or there is an association of risk factor and the disease. We assume otherwise. We assume that the drug actually has no effect, but we will try to prove it by using the statistical data. So null hypothesis is a negative assumption that we start with in a clinical study, whether it is a cohort study, a case control study, or a randomized control trial. So let me give you some examples of null hypothesis. There is no difference between group A and group B. So this is a negative assumption. There is no difference no association between risk factor and the disease. Again a negative assumption. No differences in cases and control in terms of effectiveness of new drug. So basically we start with saying that there is nothing going on. So the new screening method doesn't lead to early detection. These are the negative assumptions that we start with in a clinical study. So the question is, why do we start with a negative assumption? Shouldn't we start with a positive assumption? Shouldn't we say that our drug is effective and then try to gather the statistical data to prove it? No, we don't do like this in statistics. And I am taking an analogy from the legal system that will make this point more clear. So in legal system, what do? Do we consider that person is innocent when we start the trial, or do we say that person is guilty when we start the trial? We say that the person is innocent, and then we try to prove him guilty by gathering evidence. So in that case, the burden of proof is on police or the prosecutor to prove that he is guilty, but we start with that he is innocent. So think about it, like if we start by saying that he is guilty and then gather the evidence for the same thing, will it be fair to that person? Will that be like a good practice? No. So the same is in the clinical research or the medical studies or medical statistics. We say that nothing is going on. Then what we will do? We start a clinical study. Either it is a case control, cohort or randomized control trial. We start a study, gather the data and interpret the data to gather some statistical or mathematical evidence to prove that something is going on or the drug is effective. But we start with that nothing is going on or the drug is ineffective. So this negative assumption that we take at the start of the study is called null hypothesis. So as we have discussed, we assume everything is normal or there is no effect of the drug. This is called null hypothesis. Then a study or trial is conducted and the data is collected. And we analyze it mathematically or statistically to prove that there is an effect. The burden of proof lies on researcher. So the key idea here is that we are trying to prove that something is useful or harmful only when we have statistical evidence for it. Without mathematical evidence or statistical evidence, we cannot reject the null hypothesis or we cannot prove that there is an effect. So rejecting the null hypothesis means that we get a statistically significant data. We will discuss about that. So we try to reject the null hypothesis in favor of alternative hypothesis. What do we mean by that? So as we have discussed that we gather the data from clinical studies and statistically analyze that data. When we statistically analyze the data, we may find that data is statistically significant. That is a good news for us. So this is called rejecting the null hypothesis. Because what was null hypothesis? That there is no effect. Nothing is going on. Actually, we are failing at the start of study. That negative assumption is null hypothesis. So by gathering the data, we try to reject that null hypothesis. We try to reject the hypothesis that drug was not effective, because we have found that drug is effective. So our main aim as researchers in the study is to reject the null hypothesis in favor of alternative hypothesis using statistics. So now what is alternative hypothesis? It is the flip side of null hypothesis. It is exactly the opposite of null hypothesis. It states that there is a real association. It states that there is an effect or there is a difference between the cases and control or between group A and group B. So as researchers, again and again I'm saying the same thing. So as researchers, we are trying to reject the null hypothesis in favor of alternative hypothesis. And alternative hypothesis is represented by H1. Great. So some common examples of alternative hypothesis. Alternative hypothesis will say that there is a difference between group A and group B. There is an association between risk factor and the disease. There is a difference in cases and control. So these statements are opposite of what we have seen in case of null hypothesis. Null hypothesis was a negative assumption. Alternative hypothesis is a positive finding, right? So alternative hypothesis is a positive assumption. We don't start with it. We start with null hypothesis. We start with null hypothesis. And we only accept alternative hypothesis by rejecting null hypothesis using statistical evidence. So rejecting the null hypothesis and accepting the alternative hypothesis. That is a positive assumption. So now how do we statistically reject the null hypothesis? We are saying that we want to reject the null hypothesis, but how? So that is where p-value comes in. This is our favorite metric. So confusing, giving goosebumps in the exams, giving goosebumps during the preparation. So we will talk about p-value. Okay, p-value is used to statistically reject the null hypothesis. So let's start. What is p-value? So I want you not to look at the slides. I want you to listen to me and look at me. You can zoom out. If you are seeing it on the YouTube, you can pinch your screen, zoom me in, because I want to discuss this rather than you reading the slide, and we will read the slide together again. So p-value tells us, like, you have done a clinical study, you have gathered the data. Now data is in front of you, right? You are seeing the data. Suppose I am the p-value, or I am a representative of p-value. This data, if it is showing consistent with the null hypothesis, then the p-value will be higher. I will be happy because I am the p-value. So I am seeing the data. Oh wow, it is consistent with null hypothesis, and I win. I will feel the high. So p-value is how the data you are seeing right now that you have gathered, how consistent it is with the null hypothesis, or how consistent it is with no effect or no association. So it seems counterintuitive, because like we should have a metric which should tell us that data is significant for rejections of null hypothesis, because we are trying to reject the null hypothesis. But p-value tells us that this data is showing that null hypothesis is true, then only p-value will be high. So lower p-value will be that this data that I am observing or that I have gathered is not consistent with null hypothesis. A lower p-value means the data I am observing is not consistent with the null hypothesis, because p-value represents the magnitude that how much the data is consistent with null hypothesis. So if I am getting that value lower, that means my data is not consistent with null hypothesis. And what is null hypothesis? A negative assumption. So that means I am happy now as a researcher, because my data is showing that it is not consistent with null hypothesis if I am getting a low p-value. A higher p-value on the other hand means that my data is showing a high likelihood of being consistent with null hypothesis. That is a higher p-value. So as researchers, we will be unhappy if we get a higher p-value. So we should have lower p-value to show that the study is successful. Now let's read it. In simple terms, p-value measures how likely are we to see the observed data collected after the study if there is no effect. How likely are we to see the observed data if there is no effect, no association, that is null hypothesis is true, or these results are due to pure chance. This pure chance is also called alpha error. So p-value represent alpha error. We will discuss that in a separate video, the alpha and beta errors, but as of now just remember p-value measures chance also, and chance is like alpha error. If you have a statistically significant data, then it is very much possible, not very much possible, but there are some chances that it is due to pure luck. So this error is called alpha error. So p-value also measures that. So in other words, p-value measures the compatibility of the observed data with the null hypothesis. Great. So this is what p-value is. So lower p-value means data is statistically significant. It is not compatible with null hypothesis. Higher p-value means it has higher compatibility with the null hypothesis. So it is not statistically significant. Our study is failing. Clear enough? So I've just put this funny slide that there is a mock fight between researchers and p-value. So it may help you remember this concept. So p-value wins. So there is a mock fight between researchers and the p-value. So when the p-value wins, p-value don't like researchers. It gets high when the data is consistent with no effect. There is a data, but it is consistent with null effect. There is no effect, so researchers lose. This is what it is saying. So p-value wins and gets a high when data is consistent with no effect. It then mocks the researchers. So researchers and p-values are on the opposite side. Researchers like low p-value. Look at your data. It is showing that there is no effect. I mistakenly written as no effect. So it is showing that there is no effect. I am feeling high. This is a statement of p-value. Researchers win. Researchers love it when p-value gets low. We have already discussed that. Then they mock p-value. Look at you now. The data is showing that null hypothesis is not true. You must be feeling low. So just read it. Just have fun with it and you might be able to remember the concept better in the long run. So what does a lower p-value mean? Lower p-value means that there is a less likelihood of observed data if the null hypothesis is true. In other words, there is high likelihood of observed data if the null hypothesis is not true. Same thing. Low likelihood, less likelihood implied by lower p-value of the observed data if the null hypothesis is true, right? This is what lower value tells us. In other words, there is a high likelihood, less likelihood is replaced by high likelihood of observed data if if the null hypothesis is not true or there is in fact an effect. Correct? Lower p-value tells us that data is statistically significant. So both the above statement reflect the lower p-value, so don't confuse the second statement with higher p-value. They can give you a statement like this: the high likelihood of what is represented by lower p-value. Okay. What does a higher p-value means? There is a high likelihood of observed data if the null hypothesis is true. So as we said, p-value means the compatibility of the observed data with null hypothesis. So higher p-value means there is a high likelihood of compatibility of the observed data with null hypothesis. In other words, we have no our data is not statistically significant because high compatibility with null hypothesis means high compatibility with no effect. So researchers fail, p-value wins. There is a high likelihood of observed data if the null hypothesis is true or there is no effect or no association. So this is what the p-value measures. What p-value doesn't measure? Probability of null is true. So now you will be confused that he was talking about null hypothesis and p-value. Now he is saying that probability of null is true. So p-value, a higher p-value just failed to reject the null hypothesis, which is different from accepting the null hypothesis. Accepting the null hypothesis means that I am conclusively saying that drug is ineffective. Am I saying that? No. I am saying that we fail to gather enough evidence to reject the null hypothesis. So why this is so? Accepting the null hypothesis means that we are conclusively saying that drug is not effective. But who knows? We didn't take the enough sample size. That is why our p-value is higher. There may be bias. There may be a beta error. We will talk about the beta error in a separate video, the alpha and beta errors. But there can be many factors due to which p-value is higher. Many factors. Sample size, bias, beta error, and lot of things. So when we don't find statistically significant data or when we get a higher p-value, we just say that we failed to reject the null hypothesis. We failed to prove that the drug is effective. We are not saying that the drug is ineffective. We are saying that we failed to prove statistically that drug is ineffective. That is the difference. So keep this in mind. They can ask you that which is represented by p-value. So probability that null is true. Keep this concept in mind that by p-value we just try to reject the null hypothesis. If we can't do that, we fail to reject the null hypothesis. But it is not true that we can say that null hypothesis is true. That means we are closing all the future doors. We cannot improve our study design. We cannot take a larger sample size because we have conclusively said that drug is ineffective. Chapter closed. But if I say that I failed to reject the null hypothesis, so I can do the study again with larger sample size, with better study design, with reducing bias, all these things. So that is why. So this is a misconception. Okay. Okay, another thing. A statistically significant result, that is p less than 0.05%, a lower p-value, doesn't prove that it is not due to chance. Then again, it may be a surprise for you that he was talking about chance, that p-value measures chance, but now he is saying a statistically significant result doesn't prove that it is not due to chance. Here is the thing. I am saying I will accept p-value of less than 0.05 to reject the null hypothesis. If my p-value comes less than 0.05 or 5%, I will reject the null hypothesis. That is my presumption. But I am saying that I will still allow the room where, like, I am allowing 5% of chance. P-value measures chance. If this would have been 0, if I am saying that I will only reject null hypothesis when p-value is 0, then I am not allowing any room for chance. But because I am accepting that, okay, even if it is less than 5%, p-value is less than 5%, I am okay. I will reject the null hypothesis and I will assume that my study is statistically significant. Okay, so there are still 5% probability that results are due to chance. This is alpha error. So we allow the room for alpha error. Results are due to chance or luck or by random error. This is what type 1 or alpha error. If we would have said that we will only reject null if p is equal to 0, then we would have removed all the probability due to chance or luck. So you might think that if it is like this, that p is equal to 0, we will remove all chance factor. Why should not we take p is equal to 0 only? Why 5%? Why we are allowing room of 5% also for alpha error? The answer is that if you don't allow this room, then no study can be successful. Because there is a trade-off between alpha error and beta error. Alpha error increases, beta error decreases. Beta error increases, alpha error decreases. So it is like a seesaw. So you cannot have a perfect study where alpha error and beta error both are 0. So that is why we allow some room for alpha error so that beta error can decrease. We will talk about this in alpha and beta errors, but just to give you a brief context. So that is from where I am coming from. So because we need to leave room for chance, as there is a trade between alpha and beta error. So the point take home is the statistically significant result, which is p less than 0.05, doesn't prove that it is not due to chance. There is still 5% chance. But the chance is only 5%. So p-value, lesser p-value, means that it is lesser p-value is a metric of lesser chances. Less the p-value, lesser are the chances that the data is purely by chance. But less than 5% means there are less than 5% chances that it is due to pure chance. But still there can be a chance. If you conduct the study million times, then 5% of the times it can be purely due to chance. So that is what I mean to say. I hope this is clear. What p-value doesn't measure So p-value doesn't measure the strength of the size or an effect. P-value changes with sample size. I make a statement here. So if there is a very large sample, even a small variation or a small effect will show up. That means p-value will be less than 0.05, because that is the measure of statistical significance. You have taken a very large sample size, but there is a very small effect. P-value will be low because your sample